This is Geo-Environmental Atmosphere Forecaster Andrew Flake for your overnight Monday and on into your Tuesday morning video. Thunderstorms are expected to make their way into the Mid-Atlantic and Northeast regions for later Tuesday, and we are going to touch up with a small video explaining what this will entail, especially into those major cities. What you're currently looking at is a radar powered by our partner and affiliate Zoom Radar. If you want to follow this exact picture frame along with us during the day on Tuesday, just head on over to geoea.org, scroll down midway half to the page, and you will be able to find yourself looking at the same radar that we are. So speaking of radar, we have two areas overnight here of our midnight to 2 a.m. frame, which extends some storms at this time, even some severe thunderstorm warnings. The first is over Lake Erie, while the second is approaching West Virginia. And the models that we're looking at, specifically the NAM, which is one model we're going to look at tonight, projects both of these clusters to head eastward through the early morning on Tuesday, and also some thunderstorms even later Tuesday from a pushing front out of the west, cooling conditions for your Wednesday. So speaking of the NAM, let's head over to the NAM and let's take a look at what it has for the day on Tuesday. And what we find is the NAM does initialize these thunderstorms that we showed on actual real-time radar over Lake Erie and also West Virginia. So the NAM is not overestimating any convection. It is actually playing and initializing where thunderstorms should be, which gives us good indication that this would be a good model to use as guidance throughout our Tuesday. So with that being said, with these two areas, they will be separated for quite a bit of time. But as we reach toward the morning and we reach toward the afternoon, these cells will begin to explode. They will begin to progressively increase in intensity, and that's where heavy rain, hail, and strong winds will occur. And what I'm actually going to do here is just frame this model forward through our afternoon, and I will narrate as I do. So currently here we have our 12 to 2 a.m. time frame. So we skip on over to the early morning. The NAM projects these thunderstorms to come off Lake Erie and into West Virginia, increasing in intensity. Obviously you have our first cluster here over West Virginia, Maryland, and Virginia. You also have our second heading on into Northwest PA and New York. This again would be our early morning, and that would even extend into central Pennsylvania, maybe a wet commute for you guys out there. As we extend another 3 hours, this is when the NAM begins to really perhaps estimate or even overestimate the convection that will be shown here. This is something we're not backing away from calling an error to be, but with what the radar is showing, with it initializing correctly with the NAM and vice versa, this is something again we're going to be taking as guidance. And you can see here for our 12Z time frame all the way up to about our mid-morning, the NAM does bring that cluster out of West Virginia now into southeast Pennsylvania, eastern Maryland, Delaware, and New Jersey, while the second one up here is now impacting New York. Now these two are going to primarily stay separate, and they're actually two separate vortices, which in other words are surface low pressures. And surface low pressures can pump an area of instability from the south. Obviously a counterclockwise flow can pump that from the south and actually create their own cells and even strengthen themselves. And with us having two of those in the region for Tuesday, this is why we're going to have thunderstorms from as far south as Virginia to as far north as even New York, upstate New York, all the way even perhaps up to Boston. But where the strongest storms and the most severe storms are what we're really watching here, and which we'll also explain further in this video. But I first want to continue off with the frame here. So as we look at mid-morning, we then go to late morning, and again both of these clusters are still separate. The NAM really hits hard by late morning, Philadelphia, Allentown, approaching into New Jersey, and even New York City. Our second cluster is still moving through upstate New York. And by, of course, our late afternoon and toward our early evening, we still have that cluster of storms over Philadelphia, central and southern New Jersey, and a couple storms, not as intense up there over the New England states. There could be a reason for that, and I will explain that here on our next indice that we'll show, which is CAPE, our convective available potential energy. And what we will show you with CAPE here is something very, very interesting. Obviously, this is the current time frame of this video being initialized, midnight to 2 a.m. We had our storms being out here and through West Virginia, but our CAPE, and where our highest CAPE values exist, would be over the yellow or inside the orange and red lines. Where, of course, the CAPE would be lower is where we don't have as much available convective energy, and that, of course, in the green and where the blue area is shaded. So we obviously know that we have our one first cluster moving into Erie and out of Erie through the morning is going to be heading into upstate New York. The second one down here in West Virginia moving about due east into southeast PA, Delaware, and New Jersey. Now, what's very interesting is we have a lot more CAPE going on here in Virginia, Delaware, Maryland, southeast Pennsylvania, and New Jersey. Obviously, we have less CAPE up here over the New England states. That could be maybe what the model is looking at and saying, well, if there's not enough convective energy as much as, well, you're looking down there over perhaps the states of Maryland, Pennsylvania, New Jersey, well, some of those thunderstorms might not be as intense. That's also potentially why the Storm Prediction Center of the SPC has had more of an extending slight risk for storms further into those states southward. But we will go and animate here our CAPE image and show you what is expected throughout the morning and afternoon. Obviously, this is our current image. As we rock ourselves into the afternoon, we see some of that CAPE extending into Pennsylvania, still very limited over the New England states. Then through our mid to late morning, still a lot of that modest, not a very high CAPE, but modest CAPE over here across the southern areas of the Mid-Atlantic, and on into our late afternoon and early evening. We still have the majority of the CAPE hanging out down here across the coastal areas, Philadelphia, New York City, down to New Jersey, Delaware, Virginia, and Maryland. So the question now remains, what exactly are these two clusters and where do they come from? And we're going to show you one image that does it very best to explain this. This is going to be obviously our streamlines, where you'll be able to see where exactly these vortices are and where they track a lot more clear. So here again we will show you exactly where these vortices are and in a lot more of a clear set of images. Obviously we have our first one in here just off Lake Erie. That's where those thunderstorms are. The second one over here across or entering West Virginia. Both of them again are going to take a track like this. Alright, and we're going to see more of almost like a coiling direction. We have obviously one up here, but you obviously have a lot of the wind barbs pulling into the center, and that is what we want to look for here, especially in these two distinct areas as I animate the frame. So moving forward here, this is obviously our current image, and as we move forward through by our early morning, we can see the two vortices are now making their way through the central half of the region to the eastern half. Here obviously is your primary northern vortice and your southern one here. And you can see that with the dew points that are shaded behind this, there's a lot less and lower dew point up here in the New England states. You also have a lot more deeper blue and darker blue, which indicates a more moisturous atmosphere down here across the southern Mid-Atlantic. This also might support why conditions may be better for the severest thunderstorms, rather more south than north. And last but not least, we're going to show you, I'm sorry there, my mic was skipping a little bit. We're going to show you last but not least the supercell composite of where the model is generating the best chance for supercells to develop. Where supercells develop, that would be where the most severest of weather during Tuesday would occur. Obviously we have for our early morning here, but progressing through our frame, we have two areas again, as we watched and we pointed out. those vortices. We had one at this time frame would be here. There's a lot of limited supercell activity that the model's outputting, but the model does see with the vortice down here further south, there's a lot of a higher chance for supercells. So again, that's why we're thinking definitely the cities of Allentown, New York City, central southern New Jersey, Delaware, eastern Maryland, northern Maryland, Philadelphia, Dover, Baltimore to DC, you do have a better chance for seeing that severe weather as opposed to those further north. But here at Geo-Environmental Atmosphere, we are going to continue with updates during the day. Look for a nowcast. We want to make sure we get things right here. But overall, to sum up what we talked about, it looks as though we're going to have two clustering areas of storms moving through and eastward into the region by your Tuesday morning, lasting throughout your afternoon. Now that will sift eventually eastward. Behind that, if there is enough moisture, there is enough clearing, and ahead of the front yet, there could be a second band of thunderstorms. But for now, what we see here is what we can expect opening up into your morning hours and afternoon. For Geo-Environmental Atmosphere, I'm Andrew Fleck. Continue to follow us, and thanks again.